Okay, I thought you might need a little bit of help with this Seesaw activity. And so I'm going to walk through the steps in the answer. So the way that you might want to use this video is to go as far as you can go on your own and then check into the video, and you can fast forward along if you need to, figure out how you're doing, and then if you've got it correct, pat yourself on the back. All right, so the Seesaw activity today says we are going to synthesize, so this is a synthesis reaction of methane, CH4, 1 carbon, 4 hydrogens. And since it is synthesis, we are going to start with carbon. So I'll put that over here. And our second element, synthesis, remember, is hydrogen. Okay, there's our two reactants, arrow. And we want our product. Our product is CH, and we already know it's CH4 because I'm telling you that's the balanced product, although you would already know that since carbon has a charge of 4 and hydrogen is 1. All right, let's go back, check for diatomics. Don't want to miss that because hydrogen is diatomic. All right, let's balance the whole equation. We have 1 carbon on the left, 1 on the right, 2 hydrogens on the left, 4 on the right. So we're going to have it look like this with the coefficients of 1, 2, and 1. All right, in the problem, I told you what we're starting with, but we're going to add in the lines because they're already there for you in the Seesaw problem. These are moles, so I'm just going to draw those in. You've already got that. Grams down here. And we're going to go back and look up in the periodic table how much each one of these is in terms of its atomic mass. So carbon, 1 carbon has a mass of 12 grams. What's 1 mole of carbon? Hydrogen is 1 plus 1, so that is 2. And the last one over here, CH4, well, that's 12 plus 1 plus 1 plus 1 plus 1. So that is 16 grams, okay, for the atomic weight of methane. All right, I told you we were going to start with 48 grams of carbon, and we're going to start with 12 grams of hydrogen. Now, if you notice, there's one more thing on your worksheet that I haven't put into here yet, and you can add it in at the beginning. I'm adding it in at some different points, as you might notice. So I'm just going to go ahead and put it in now. The heat, delta H, the heat from our standard reaction is 74.8 kilojoules. Notice I don't do any balancing with these things. There's no 1s or 2s or 6s or anything else in front of the kilojoules. It's just 74.8. It's not involved in the balancing. Don't even try and do that. All right, and I'm going to add one more line above it because it is kilojoules. And remember, that's Q. All right, now we're ready to go. So let's do some division. 48 divided by 12. Put the answer right up here. That answer is 4. All right, let's do another one. 12 divided by 2. 12 divided by 2 is 6. So I'm going to do some circles here. And let's see what is limiting our reaction. We have 4 divided by 1. Remember, we're doing division here. 4 divided by 1 is 4. 6 divided by 2 is 3. And so this is the smaller one. Wow. Notice that 6 moles and the other's 4 moles, it isn't about how many moles there are. It is about the division, the ratio. 6 divided by 2 is 3. So this is the one we're going to use. Remember, this is X. So we're going to use 6 divided by 2 equals, and I'm going to use my same yellow one here, X over 1. X over 1. And so if you do that division, you'll find out that that one is 3. All right, now for our last one over here, for the heat energy, I'm going to change colors just so that you can kind of see that. This one right here, we're just going to use our same limiting one there. This one right here, 6/2 equals, this time Q over 74.8. And just do the cross multiply and divide. So 6 times 74, 6 times 74 is 444 divided by 2. Let me make sure that's 74.8 times 6. All right, 448.8 divided by 2, 224.4. Okay, that is the answer. Don't go any further with it. Don't try and move it down below. Don't multiply it by anything else. That's the final answer right there. How many joules of energy were produced? 224.4 kilojoules. Don't forget the K there. One last step here, though. We do have to figure out our mass. This is 3 times 16 is 48 grams of methane. So when we take 48 grams of carbon, 12 grams of hydrogen, we get 48 grams of methane, and we get 74.8 kilojoules of energy. Okay, so all we've done is add energy into this whole process.